My name is Amey. Today I'm going to give a small talk about the concept called Inkeption. So this is quite unique concept. It's named after the movie called Inception. So I hope you might have watched that movie. So I will talk about it later, like how I end up naming this project as Inkeption. So first of all, like I will introduce myself. That I'm Amey Deshmukh. I'm from India, Pune, and I'm working as a site reliability engineer at InfraCloud Technologies. So if you don't know about anything about InfraCloud Technologies, then we are the one of the first companies who partner up with Kubernetes from Asia Pacific, and our work is mostly around with consultation related to the containers, Kubernetes, and overall cloud native ecosystem tools and technologies, I would say. So after this introduction, let me like first explain like what is Kubernetes and kind to those who don't know anything about it. So Kubernetes is a container orchestration tool. So you might have heard about Docker. So you know that we can spin up Dockers and we can uh, give an isolated environment for any processes that we want to run, and Docker just helps in achieving that isolation. So we can create and orchestrate like so many number of containers using the Kubernetes tool. And this Kubernetes actually is a cluster of nodes that we call them as worker nodes. So on top of those worker nodes, probably there is a Docker daemon running, and so it helps the worker nodes to run the containers, which are actually controlled by the API server. So API server and kubelet, and there are so many other components as well as part of Kubernetes cluster. So actually, they work together and help the whole cluster to work as expected, where we can scale up our cluster, scale up our containers, and basically like run our microservices in the form of containers. So that's a small introduction about the Kubernetes. So what is kind then? So, as I said, that the Kubernetes cluster is mostly having virtual machines as Kubernetes nodes. So, if we see any managed Kubernetes service from cloud providers like AWS or Google Cloud or Azure, so they provide the virtual nodes as the Kubernetes cluster nodes. So they could be very powerful. Like they come from the range of any virtual machine instance specifications. Maybe they could be having 2 gigabytes of RAM to literally having 200 gigabytes of RAM. But like obviously they are like built for production use only. Uh, but when it comes to developer and developer machines, so there is a project called Kind. Its name stands for Kubernetes and Docker. So what it actually does is it can spin up a Kubernetes cluster, which is a dev cluster, I would say, on the laptops of any developer. So it only requires Docker engine to be installed on that laptop machine, so that you can like create a mimic of Kubernetes cluster, which is on which like you can deploy the workloads and deploy the containers in the form of Kubernetes resources. So yeah, it actually there are a few alternatives as well if we want to like create the dev clusters, such as Minikube. You might have heard it because it's quite famous, and there are few more as well like K3s and yeah, I can't remember the other one's name, but yeah. So Minikube actually used to like use the driver of virtualization. So earlier it was VirtualBox, but then later they have also supported Docker as their driver, so that they also use the Docker containers as the Kubernetes nodes. So yeah, that's the speciality of Kind cluster, that it creates Docker containers on your local machines, and it treats them as the Kubernetes workloads. Worker nodes. On top of that, on top of which like you can deploy your workloads. So yeah, again the question comes like, what is Encaption? So as I said earlier, that you might have watched the movie Inception. So in that movie, a group of people navigate through dream, and from one layer to dream, they go deeper and deeper. Like they achieve that concept of like dream within a dream and within a dream. So the similar concept we achieved while working for this project. So earlier I named that project as KTES in a pod in a KTES. That is Kubernetes in a pod in a Kubernetes. But actually, I found that we were actually achieving the multiple layers of Docker. And we were like deploying the final workloads in at least like fourth or fifth layer of Docker container. So that's why I tried to give it a funky name. And as Inception is also my favorite movie, that's why I renamed it to Inkeption. So let's talk about the architecture of Encapsulation. Uh, so you could be having one Kubernetes cluster. This Kubernetes cluster could be running at anywhere. I would say not necessarily it has to be run on any managed cloud providers Kubernetes service, that is EKS or GKE. But it could run on your local machine as well. So there you will be having a worker node on which we will be deploying one. So uh, this is the worker node I was talking about. So yeah, on top of which we would be deploying a pod. So pod is a wrapper around container. So in a pod we can like deploy one or multiple containers. And yeah, so under that pod container we will be spinning up a kind cluster. So again, that under that kind cluster we can again deploy like Docker containers or any workloads. So that is a high level architecture of this encapsulation concept. We will like talk about each of its layer, like how can we achieve this, which Docker image to be used for this pod, and like what kind of commands need to be run for spinning up that kind cluster. So we will discuss it in the next slides. So again, when I created this POC project and shared it on,
Amey, just a quick one. Are you
yeah.
sharing? Because we can see you. I wasn't sure if you had slides, but from what you just said, I think we should. Yeah.
Okay. So sorry, I forgot to share my screen.
Yeah, because we shared the test and we didn't go back. Sorry, guys.
Yeah.
Maybe a quick recap.
I'm so sorry.
Slides.
Thanks,
Right.
Dennis, for reminding me.
Kashka.
Okay. So I think we are at here. Okay, so this will help you again, like to get the idea of the architecture that I was referring to this picture. I'm so sorry that I forgot to share my screen. So yeah, so under this Kubernetes cluster, we will be having a worker node where a Docker daemon will be running. So using this Docker daemon, pods will be created, and pod is nothing but a wraparound container. So a one pod can have multiple containers as well, or at least it must have one single container. So yeah, so we will discuss like which Docker image to be used to spin up a kind cluster within this pod, and in the next slides, obviously, and like how can we like create the kind cluster and what commands it needs and what challenges I faced earlier. So that we will discuss in the next slides. So yeah, that was the motivation. So when I actually created this POC project, so many people have asked me like, okay, this sounds really crazy that we are spinning our Kubernetes cluster inside a pod, and that pod is also running inside another Kubernetes cluster. But why do we need such complicated architecture? So well, actually, while working in a project, we had a very unique use case where we were supposed to test one workload, which was kind of an admission controller in the Kubernetes. So if you don't know about what is admission controller, then I will give you a quick idea. So by using an admission controller, you can like either validate or mutate any incoming requests that are coming to the Kubernetes cluster. So for example, if someone is trying to create a pod with any Docker image with the latest image tag, then and if you don't want that any pod to be created with latest image tag, then we can set up a validation policy and we can deny that policy so that no user could ever be able to like create a pod with latest image tag. So that's generally considered as a best security policy because it helps you keep a track of like what kind of Docker image a pod is been using, so that we can roll it back, and it has its own benefits. So that was just an example, like what is actually a validation webhook, or sorry, admission controller. So admission controller is nothing but another deployment. So that gets created as a Kubernetes deployment, and that actually works as a gateway to your Kubernetes clusters, and it actually validates whether the incoming requests are uh, as per expectation or not. So yeah, so by using that admission, like we wanted to test the admission controller deployment, and so that admission controller was supposed to like create custom policies for that cluster, and that was going to impact the other workloads. So we didn't want our CI/CD cluster where we could like test that admission controller, because we wanted a isolated environment, so that even if that admission controller like enforces any other policies, so it won't impact the functioning of rest of the services or the workloads which are already running on that cluster. Might be other people are also using that cluster for other purposes, and we didn't want to create any impact on that functioning. So that's why we wanted a I would say an isolated environment. So again, we could have created like EKS or a GKE cluster, so that we could get that isolated cluster. But the problem is, like, if you have used Terraform for spinning up the AWS cluster, or even CloudFormation, then you might have noticed that it takes around 10 to 15 minutes to just spin up that cluster. And uh, we were running Kubernetes or containerized workflow to test out the complete CI and the CD operations. So, so if that workflow is taking like 15 minutes only to spin up that cluster, so that would have the whole workflow would have taken more than half an hour or 40 minutes, and we didn't want that. A pod is continuously being running, the workflow pod is continuously being running for 30-40 minutes, and that will just keep the resources occupied for that much long period, and that is not really a good ideal situation. So yeah, that's why we decided to look for other options. uh, so that comes to the next part as well of the slide, that where exactly that Encaption concept can be utilized. So again, so if we are running any CI/CD pipeline on top of Kubernetes, that is in the form of pod, such as Argo workflow, or if you are running your Jenkins, which is a CI/CD tool on top of Kubernetes. There is one more tool called Tecton as well. This also uses Kubernetes pods as underlying, or the Kubernetes resources as its underlying components. So in that case, we could like spin up the kind cluster within that pod itself, and use that kind cluster to deploy our workloads. So this will like give us a fast track speed for like testing out or deploying out our applications. And maybe if we can build our own custom testing utility tool or framework, then from the client side itself we can like make some calls and like test out our deployment or workloads, whether they are running as per expectation or not. So that is I'm going to cover in the demo as well. So if you don't get it right now, then just hold on. So yeah, so just to like extract what I talked about, like why did we go for the Encaption concept, is of course like spinning up a kind cluster within the pod is really cheap, and it is really fast. Like it will take hardly a minute, even on the smallest EKS nodes. That is only, that node has only 2 gigabytes of RAM, and on that node as well, like it creates the kind cluster within a minute. So yeah, and it is cheap, so there is no really big huge difference on your cloud bill if you want to like spin up that cluster. uh, Again, like we wanted to like dry run our deployments, so that whole process become very quick. That also gave us the isolated environment, that is the Kubernetes cluster. And once that environment or the Kubernetes cluster was provisioned, then we use that cluster to deploy our workload, and we perform the automation sanity testing on it. So I will cover up like what sanity testing we perform or what it can contain, which might suit your requirements as well. So in the next slide. So yeah, the integration testing. So integration testing contains the intercommunication of the microservices. So let's consider this example, you have multiple microservices which are deployed in the form of pods, and you know that uh, all the microservices try to communicate, or some of the microservices try to communicate with each other, and few of them could be using any managed service as well, an S3 bucket. Maybe it can be uploading some data in it. It can be using the database as a DynamoDB or an RDS instance, or it could ask Lambda function service to like perform some computation and get the response from it. So yeah, this is what actually a cloud native application means, right? So uh, your application must be compatible and ready to integrate with these cloud native services, and I guess that's what a cloud native application means. So if you want to test that, so writing only unit tests for your code is really that can only help you test out a sample test block or sample code block. But when you want to like test your whole services as a single unit, uh, then we can like consider the integration testing. And for the integration testing, we obviously need to deploy those applications and test out with test out its integration or compatibility with rest of the services. So yeah, as I said that we could test out this integration with cloud services as well. So I have it gives you kind of an idea why we want to deploy the application in the first place, for like performing the integration testing. Again, we can test out our K-tests or Kubernetes deployables as well. So very common form of deployable files are like the kube YAML files, the YAML files which consist of the deployment spec, the service spec, and the other Kubernetes resources spec like config map and secret. So what generally happens is you must be having a team of operations and developers. Your developers might want to add some secret or config map in your deployment, one of the deployments, and that may not end up being compatible when it gets deployed on the cluster itself. So what we want to do is we want to find out such potential problems. So the best option is obviously to like deploy the services or the deploy these YAMLs as early as possible whenever they get committed in the CI/CD pipeline itself, so that when they it is very rare case, but even if it happens due to a human error, then we should be able to like mitigate such potential problems as early as possible, so as to like save the time of QA team, or maybe your save the resources of your infrastructure. So that could be achieved by deploying your applications. Again, Helm chart. So Helm is also package manager for Kubernetes resources. So again, its compatibility also sometimes become complicated if you are using Helm templates as such. So you really want to validate whether your Helm templates are populating the correct values in your YAMLs or not. So that also could be a challenge, or that also needs to be validated first before you actually deploy or create or install this Helm chart on your such a QA environment or maybe a dev environment. And the last point is really important, that we want to validate the compatibility with multiple Kubernetes versions. So the compatibility of the Helm chart or the Kubernetes YAML files, because what happens is, suppose in case like you are maintaining one application, and that application is available as SaaS service as well, where you are deploying them on your own infrastructure, but you are also making it available for your on-premises clusters, where those customers could like get the YAML or the Helm chart from you, and they want to deploy it on their own infrastructure. So in that case, you can't guarantee that whatever the Kubernetes version that you have on your infrastructure is going to be same in your client's environment. So that's why we want to make sure that these YAMLs are compatible with all the Kubernetes versions. In almost in every 3 or 4 minor versions, some of the Kubernetes resources, API versions, and the YAML specs get changed. And so it's obviously good best practice to uh, keep your YAMLs and deployables compatible with different Kubernetes versions. Again, if you are working on some Kubernetes extended components such as CRD or operator, then also you can use the Encaption concept for in the CI/CD pipelines. I don't want to go in detail of CRDs and operators as I'm not really an expert here, but these are the extended components, or you can extend the functionality of Kubernetes by creating the CRDs and operators. These are both different things, but I don't want to go into details because it is slightly out of our topic of discussion today. So now the part comes like how did we achieve, or how actually could we achieve this Encaption concept. So first and most important thing here is, as I said, that we are going to spin up a pod, and that pod, under that pod, we are going to create the kind cluster, right? So to create the Docker image for that pod uh, is actually a challenge. I mean, that's where we want to add some installables in that Docker image. So you could see that in the first part, we use the Ubuntu as its base image, and then we added few tools which helped me debug the initial issues, and then we installed the Docker in it. So we install only Docker CLI in it, so we don't really need to install the Docker engine. So in case if you have installed Docker in your local machine, then it some most of the times you might have ended up installing the Docker engine as well, because Docker CLI communicates with the Docker engine, and that's how you make the commands to that engine to whether run a container or a create image, whatever it could be. So yeah, so here we were going to use the Docker engine of the underlying host. That's why we only installed the Docker CLI. And in the second part, I just divided it for making it understand, but it's only a single Docker file. So yeah, in the second stage of this Docker file, I have installed the kubectl, so the latest version of kubectl. So these steps describe how can we install kubectl on the Ubuntu machine, and of course the kind binary itself. So one more reason why I chose Ubuntu as its base image is because kind is I mean the ready-made kind binary is available for Ubuntu machines. So if in case if you want to use the Alpine image, which would help us reducing the image size, but that at that case the kind binary is not readily available. What we might want to do is we might want to check out the kind code from GitHub, create the binary in its first stage, and then copy it as the executable for the Alpine images. And I just wanted to do it for a POC, that's why I didn't do it. But yeah, there is a scope for image optimization for this particular Docker image. And at the last, we have this create kind.sh file as the entry point of this Docker container. So whenever this Docker image will be executed as the container, this is the point where the process of the container will get started. Yeah, so again, this is just a bash script. I have added it as the entry point of the Docker container. So in that, we create actually a test cluster for kind. I mean, the name of the cluster is kind. And while doing so, so as I mentioned earlier, that kind was built to be executed on the developer's local machine so that they can mimic the Kubernetes cluster on their environments. So its networking was also built or configured in a way that it assumes that whatever commands have been run, it assumes that the host machine, or on top of which the Docker containers are going to be created, its IP address is by default 127 by .0.0, which is the localhost IP address. and that's where actually the problem starts. I mean, when I was working on it, I faced this that the IP of this Docker container or the host Docker container was completely different. It was not the localhost IP address, and that's where I needed to add some custom scripting to find out first the IP address of the Docker container in the obviously, like, we were supposed to like had this network shared with it. Uh, and yeah, so I found out the IP address, and that IP address became the, I mean, is actually the IP address of the API server of the Kubernetes cluster. So don't worry, like I will in the demo I will show it to you. So, and the, yeah, the 6443 is the default port of Kube API server. So if it was like, if this kind create cluster command was executed on our local machine, so it would have worked with the localhost IP address and the port 6443 very without giving any error. But as we were like spinning up in the uh, pod container, that's why like we had to like first fetch the IP address of the API server by running this command, and then add it in between this HTTPS URL. So yeah, once it is done, like we have to update this thing in the kube config file. So the kube config file actually have all the necessary information in order like to like create the communication between the Kubernetes client, that is the kubectl binary, and the Kubernetes API server. So using this command like kubectl config set clusters, and this we can update any API server's URL in the kube config. So that was the bash script by using which we can create the kind cluster. And the third and last, I would say, important part of the pod that was the pod configuration. So yeah, as we were like running our Docker image, like which was built on the Docker file, which I showed earlier, that that Docker image has a Docker CLI installed in it, but it doesn't work that way, because we need to like add few volume mounts in it. I have given the volume mounts here, that this is the Unix socket where Docker daemon is running. The directories where the kernel modules are present and the C groups are present, and it also needs one directory for Docker's root as a Docker root directory, where actually it stores all the images and the containers and the volumes and so on. So these many volume mounts are required for like running this container like as a pod container in a Kubernetes cluster, and that's where exactly it becomes a bit insecure, I would say, because we are running this container in a privilege mode that is also not recommended, or that is not considered as the best practice of Kubernetes. So yeah, so let's quickly go to the demo. We have one, so I have created one application here. So first what we will do is like we will create one Argo workflow. As I mentioned, that Argo workflow is a pod that will have the Encaption Docker image, and under that container we will be like spinning up the client cluster. uh, on that client cluster we will be deploying one sample app that will have a deployment and a Kubernetes service, and that sample app will try to like communicate with an AWS managed service called RDS. So it will try to put some data or get some data from that RDS instance, and once that is working or the pods are running, then we will try to test it out using the tester CLI. So I will show you that like what exactly tester CLI does. So let's quickly move to the uh, demo. So I have this workflow already written. So like first, like it will create the kind cluster, and then like let me first execute that workflow. So by the time it is being executed, I can explain the workflow itself. So we can run Argo submit uh, Argo list submit workflows.yaml. Okay. So we can see that a pod is being created with this name. Yeah, so it's in running state. So I will like follow its log, uh, kubectl logs. It has multiple containers, so I'm going to follow the main containers log, and that's it. So yeah, it has started like creating the kind cluster. So we are like watching the logs of a pod, and in that pod, so it has started the creating the kind cluster. So yeah, meanwhile, it creates the cluster. I will show you what exactly we are doing. So once the kind cluster is being created, then we are fetching the Git repo, that is the Encapsulation Git repo. So under which I have added the deployable files, that is the deployment file and the service.yaml file. So these are the deployment files. This is the deployment file. It has a service called books. It is only as a REST API service which accepts a get and post request. And to like enable to like access that pod, I have created one Kubernetes service. And yeah, so once we deploy that, we will be able to see it in the logs that whether the pod or the deployment is created or not. Then once the pod is being ready, then we will of course, yeah, wait for that pod to get running state. Then we will sleep for some time because it works so fast, and I have put some sleep commands in it. Then we will like list the pods. If all the pods are running, then we will like expose the service by using kube port forward, because I couldn't expose it using node port. I was facing few challenges, but I guess that's also possible. So yeah, so once I run this kubectl forward port forward command, then that service becomes available for the host container, which is this container of the pod, at the port 30,080. And then I have hard coded this value in the tester utility. So that is also a CLI tool. It actually uh, runs the makes the request of get and post. So with post, it actually sends some sample data and checks if that book service is able to like fetch that data and is able to store it into the RDS server or not. So that's how like we are testing out the integration between this book service and the RDS, or I would say AWS Cloud's managed service. And then once the tester execution is complete, then it will like std out all the logs it has performed. Once that testing is closed, then we will like delete this cluster using this command kind delete clusters, its name followed by its name, which is the test. So okay, so by the time I was explaining this, that workflow got executed. So we could see that the nodes were created, the kind cluster was created. Then I updated the API server's URL, and it was having this IP of that Docker container, which was 172.17.02.2. It wasn't definitely the localhost IP. So once I updated this in the kubeconfig, then I was able to run the kubectl commands, and I could run the kubectl get node command. So it pasted out the it printed out the output of it. Then once the kind cluster was ready, then we deployed this. So we created this deployment and service. Uh, then the pod was running, so we port forwarded to this IP. I mean that the this is the local host IP for that host container, and then we executed the tester utility. So we found that in the logs of it that it got the response of 200. That is okay for the get request as well as the post request. That means that the the service is being working fine with the integration of the RDS service. And once that is all okay, so uh, we deleted the cluster, and I guess that cluster is also deleted. So yeah, that's how we like finished our workflow. And after this, I guess. Yeah, it has some cons. Like as I said earlier, that we are running the Encapsulation pod in a privileged mode. We are exposing the few host path directories, such as the kernel modules directory and the C group directory, which is really not recommended at all. So it's definitely recommended from me personally that we should create our own Docker images for that, and so that we could be able to like have some control over like what exactly the process from that container is doing. So if it is not doing any malicious activities, or if it is not playing around with your kernel modules, so we can have control only if like we can have our own Docker image as the host container image for the pod. It has some limitations as well. Like the kind cluster is like supposed to be built as a dev utility tool or developer helper utility tool. So we can't really have a large applications deployed on it, such as like if your application is having 20 or 30 microservices, and even if that single microservice is having one replica at least, then I don't think like whether this small kind cluster would be able to like able to manage all the containers or not, or pods or not. Same with the PV and PVC. Like again, with the actually production ready Kubernetes clusters, we also have persistent volumes and persistent volume claims. So those are not really viable options here with the kind cluster, because we are mostly using the host path. So we won't be getting like that many options for PV and PVC in the kind cluster. And yeah, as I said, that it's not a good match for deploying large applications. So that are all the cons it comes with. um, to sum up, like including your sanity testing of your Kubernetes workloads or your application, if that application is small, of course, then it could be like really this concept is could be could come really handy, so that like we can create the Kubernetes clusters on the fly, and that too at very cheap rate, and quickly as well. So yeah, uh, then of course, like we want to have our CI/CD pipelines to be containerized first, because if you're running your CI/CD pipelines on virtual machines, for example, like if you're using GitHub Actions, then GitHub Actions doesn't need Inkeption concept as such, because you can create a kind cluster on virtual machines very easily. So yeah, so this concept could be used only where containerized or pipelines are used for your CI/CD purposes. And yeah, so provisioning of a dry run cluster using Kite in containerized pipeline or process is comparatively cheaper and faster. So again, it comes with a few complications, and it makes your cluster a bit vulnerable, or I would say a lot vulnerable. So you must be knowing like what you are exactly doing. So, and yeah, if you want to really want to study or deep dive more in this Encapsulation concept, so it has there is a blog. So like I have also taken some reference from this blog. I have given the link in my GitHub repo, so you can go to this blog and read more about it, like what challenges and risk it has like while achieving this kind cluster in a Kubernetes pod. So there is one more project called King. So while I was publishing this, so in parallel, so there was team from Istanbul. So they were also building this tool. They also took the help of this blog, and they have built one CLI tool which facilitates the Kubernetes cluster in the pod. But they have built one tool, and mine is not a tool. Mine just I was just explaining one concept called Encaption. So yeah, you can also visit their GitHub URL and like learn more about it. So that's also a notable mention I wanted to tell you guys. And yeah, that's all about the Encaption. So I would really recommend you to like try it out just for learning purpose. It's definitely not a good fit for your production use case uh, in most of the cases. But yeah, you should try it out, and let me know like what is your feedback or what is your take on this. So yeah, Dennis, over to you.
Nice one. Thank you, Amey. There is one
Yeah.
quick question in the chat. I don't know if you want to see it. It's will there be a version for other container runtimes from
Okay, let
question?
me check the question.
Yeah.
So is he sharing? Okay, sorry.
Oh, it's at one at the bottom.
Yeah, good stuff. Will there be a version for other container runtime? Yeah, so yeah, I think we can run Podman as well instead of Docker. That's what you were asking, right? So if the question is about like to find alternatives of Docker and use Podman instead, then maybe I think it is possible. I haven't tried it out, but Creo, yeah. So Creo is another alternative, right? So Kubernetes is moving away from Docker. Yeah, right. So I think it should be possible, but it could need some other volume mounts or it could need some other configurations. Uh, that I really don't know right now. But yeah, and there is one more alternative to like kind cluster, that is K3s. That should also work. Even I tried Minikube, using Minikube instead of kind in that pod, but it was failing just because it needed at least 2 gigabytes of RAM to just like start up. And even when I like provided that much RAM and memory and CPU utilization, CPU for the Minikube, so that time also it was asking like a non-root user to like use the Minikube cluster. So yeah, I guess kind is the most perfect fit for such concept when you want to like spin up a Kubernetes cluster inside a pod. That's no, but you can definitely reach out to me on Twitter and LinkedIn and share your experiences.
Yeah,
And I'm
brilliant.
so sorry, like we ran out of time. So
No, that's good. What I'll do is I'll get this video up onto YouTube. Probably it'll be later today or tomorrow, and then I'll stick it on LinkedIn. And then if anyone does have any questions, I'll ping you in that, and you can respond. Brilliant. Well, thank
okay,
you very much. Cheers,
thanks,
guys.
Dennis.
Have a good day, and yeah, we'll see you at the next one. All right.
Yeah, bye guys.
Thanks very much, everyone. Take it easy.
Thank you, Dennis.
Bye.
Thank you, Amey.